First and foremost, I would like to greet everyone. I'm Ismail Yusuf Abshir, graduate student at Jan University, majoring in Transportation and Communication Engineering. I have been working under Professor Juan Leo as my supervisor for the past 1.5 years, where we have been studying and conducting experimental research on concrete pavement that during the day absorb light energy and which during the night it emit the absorbed energy in form of visible light for an extended amount of time. As you may can see, the title of my research is Experimental Study on Preparation and Mechanical Properties of Artificial Glow on Stone Concrete Basic Pavement Material. As we all know, roadway lighting is important for drivers and pedestrians. However, this roadway lighting device induces light pollution, which is adversely affecting our environment, safety, energy consumption, as well as our health. Thus, our research team undertook an investigation on something that may be used to replace outdoor lighting devices. Artificial glow on stone concrete, also known as self-illuminating concrete, is a technology that replaces old roadway, parking lot, sidewalk, and outdoor recreation surface from reflecting into absorbing and retaining light, and then emit the retaining light in form of visible light. Driving at night can be dangerous, especially in low light areas. But imagine a highway road lighting ahead of you, how much safe it is. I mean, there will be improved visibility of pilot landing this type of concrete. Our road and parking lots are just sitting there, reflecting the sunlight and absorbing the heat. The material I use for developing this type of concrete include artificial glowing stone, standard sand, limestone, and white Portland cement. The preparation were primarily followed by the Chinese specification. 4 specimens were prepared for each combination. Among them, the first one was used for the observation of its luminescence. The strength value of each sample were then determined by the other 3. Furthermore, evaluation of real-world application were done, ultraviolet rays agent resistant, along with thermal stress test. As shown in figure 1, before the luminescence of the sample could be measured, the sample is need to excite by light source, so 150 xenon lamp were used to excite. The results show that the excitation time has effect on the luminescent duration, while the specimen with 45% of artificial glowing stone performed the best. On the other hand, after glow decay, as shown in figure 2, was faster during the first half hour. In conclusion, after the specimen fully excited, it can emit light up to 6 hours. The developed specimen were then subject to ultraviolet radiation of 114 watt per meter square with an experimental temperature of 60 centigrade for 83 hours to evaluate the real-world practicality. There were no chemical degradation observed during the experiment. However, the specimen luminescent intensity slightly changed, which due to the hydration product on the surface of the sample could cause it a portion of fluorescence to conceal. 2 tests were designed for the thermal stress test. The first one was to replicate daily temperature fluctuation. The samples were placed in microwave oven and heated up to 60 centigrade at a rate of 1 centigrade per minute. Finally, the specimen removed and let it cool in an open air. As a result, no crack or deformation occurred. The second thermal loading test was simulate the severe climatic condition by heating the specimen up to 100 centigrade at a rate of 5 centigrade per minute. As a result, artificial glow on stone concrete basic pavement material that contained 45% and 35% of artificial glow on stone displayed a tiny visible deformation. Mechanical strength were also performed. The proper addition of artificial glow stone can improve mechanical strength of artificial glow stone concrete basic pavement material, while it has a negative effect on the strength when the content is too high. Moreover, the specimen with 25% of artificial glow stone shown the greatest compressive strength. Nonetheless, all the artificial glow stone concrete basic pavement material shown better compressive strength than the control group. Based on the tests performed on the designed specimens, it is possible to conclude that artificial glow stone concrete basic pavement material has potential in use in real world by replacing part or all roadway lighting devices. The artificial glow stone concrete basic pavement material can not only reduce ecological light pollution and reduce energy consumption, but it can also eliminate the problem of illumination and glare caused by the roadway lighting devices. Finally, I would like to express my gratitude to my supervisor, Professor Juan Leo, for his assistance in helping me grasp the money concept and judgment variables that contributed to this project's success. Thank you for your attention. Have a good day.